of the meetup, so you guys have it. Basically, it's a tool that we use for our visualization. So basically, I mean, a large part of what we do is generate a ton of charts. And we have to do this really quickly, and we don't necessarily deal with big data sets on a per chart basis, but we do have, I mean, they're very decent size, and we just need to be able to crunch a bunch of data about them. And it's kind of an ad hoc thing per chart. So Framian's really just trying to do that. And so it's basically, yeah, it works with tabular data, so you kind of think of like a CSV file. It's kind of like, well, if we wanted to work with that in Scala, what would it look like? And the key kind of thing is it has to work with heterogeneous data, so it's not just like a matrix or like a bunch of numbers. It's got dates and text in there and, you know, categories and that kind of stuff. Obviously, it has to be fast, because I like things that are fast. And should be, you know, like, be able to handle real-world data. So, like, you know, we're quite often missing values, or, you know, there's errors in our values, and we want to be able to make sure that those are handled in a sane way and not just, you know, thrown out. Yeah, so my disclaimer is basically that Framian itself is still in beta. There's still a lot of changes as we kind of use it and we see what we need from it. So there's obviously a lot of bugs as well. Of course, it's in Scala. And the other thing, too, is like this, there's a couple of branches that I use in this that aren't currently merged into master. One of them is CSV, which just redoes our CSV support. It's a lot nicer now, but just not in master yet. Same thing with a little bit of stats. So before anything, we're going to kind of have like a running REPL session in a way. So we have to basically import all this stuff, basically our Framian things, but also you'll see that we have Spire there. Framian makes heavy use of Spire, partly because I am one of the co-authors of Spire, but partly because it's also great. Okay, so Framian, what does Framian look like? So here we're basically using the CSV object we have. We can basically parse it and turn it into a frame. So this is actually printed the toString for a frame, so when you run this, you'll actually get something that looks like this. All throughout these slides, I'm basically always cutting off a bunch of rows and a bunch of columns because this is a big data set. But this is kind of the data set we're working with through the entire presentation. It's kind of a well-known one. It just has a bunch of auto-carved data, so you have, like, you know, the main thing is you get the miles per gallon, and you have all this data that is associated with the cars, and you can kind of try to figure out like what the miles per gallon are going to be based on the other parameters. There's a few things you'll notice. Our frame is generic. It has two types here. It's parameter has an int and a string. Those are actually the key values. So we have our columns and our rows. So our rows are keyed first. Those are ints. It's a CSV. So we have, like, you know, your first row is 0, obviously. You know, up from there, and then because we did two labeled frame, we also take the first row of the CSV and we say that that's actually how we want to index our columns. Yeah, so you can see our column rows here. Basically, it's a string. That's what it is. And then we have all our lovely data. And you'll notice here that while most of it's numeric, we also have some text data here. So that's kind of what I was driving back, is that it's a heterogeneous frame of data, not just a bunch of numbers. If you are kind of either been around Scala for a while, or you've kind of looked at this stuff before, you'll know that this kind of looks like a library called Saddle. I must say Saddle is fantastic. It honestly is super awesome. Just that we were actually using it first. It just wasn't quite what we needed, because the main thing is that Saddle's typed. All the values always have the same type. So they're numbers or dates or whatever else, they always have the type of numbers. And so they do have some basic support for heterogeneous data, but basically what it is they're saying it's anything, and then they just, you know, cast things as needed. It wasn't very nice, and it made a lot, that using it as a heterogeneous frame wasn't super great. So it made it difficult for our use case. So we built this tool to kind of deal with that. So as I said, ours does not have the value type. So, you know, it's kind of, I guess with Scala, you kind of expect to have types all the time, and we kind of throw those away. But you'll see that it doesn't really hinder us too much in this case. So the main thing is that whenever you access data, you have to specify the type. That's how things are typed. You say, you know, get me the column as numbers, or get me the column as text. We have, you know, this allows us a lot of flexibility too, because if you have a column and, you know, maybe full range of data and you ask for it as a double, it should still work. I mean, you shouldn't have to know that whether the person gave you a column of doubles or big decimals or whatever. Yeah, so getting values out. So we loaded our frame earlier. So basically, one of the easiest ways is just to get a single cell of data out. So in this case, we had our two ways of indexing the data with the rows and the columns. So we're just saying, give us the 333rd row, 334th, I guess, really, your index, and column horsepower. And we get back the value eventually. Yeah, so you get back the value. It has 132 horsepower. You see it has this little cell thing. We'll get to that in a second. Because I'm going to say, well, give me the name of the same thing as a string. We get back stats in 2 ADs at x. Lovely. So you can see you can ask for the horsepower as a string. We do get back a value. And that's just because we generally say that we can turn things into strings. Because Scala. As I mentioned before, though, we are flexible. So, like, while the horsepower is really like 132, if you ask for it as a big decimal, you should still get it back as a big decimal. If you want to deal with it, have more accuracy, you should be allowed to do that. Yeah, same thing, because it actually was an integer, it's 132. If you do ask for it as an int, it will return a value as well. And the main thing here is that we're working with numeric data in a frame. We're not working with like doubles or big decimals. We're just working with numbers, or real numbers. So then there's the question of, what happens when things aren't so hunky-dory, right? So before, we're able to get the horsepower value out of that pretty easily. You can see in our table, it's right there. That's the row 333. There's a value there for horsepower, 132. But if you look a few rows down, the Mustang Cobra, the horsepower column, which is right here, is actually missing. So when we ask for it, we actually don't get back value. We get back sentinel value, NA. Basically says that this data value is not available. It's missing. Another thing is, like, what happens if we ask for, say, the name as a double? It doesn't make sense. We can't turn that into a double. It's not a double. In this case, you'll get back another type of sentinel value called NM, which is not meaningful. So that basically means that there's some data there, but it doesn't make sense for how you ask for it, or whatever.
Question.
Oh, yep.
So the difference between interpreting that dash as not available versus a string that did properly, is that a nuance of the extracting it from the CSV?
Yes, that's part of the CSV parser. So the CSV parser will try to auto-detect a lot of stuff. So they'll try to figure out what your missing values are, like whether it's like you've had n/a or dashes or just nothing there. They'll also try to figure out if column types are like numbers or text.
So and you can write your own extractor for CSV file and figure out something else.
Yeah, I mean, more than likely you'd use a different CSV format for the parser. Okay, so basically, the main thing I was driving here is we have these things called cells. Cells are kind of like the fundamental thing. They're a little zero-dimensional data structure that has a single value in it. So we have 3 cases, which is a value, yep.
So this is just maybe restating what you just clarified, but non-sentinel means you can't parse it correctly with the target desired. Right?
Sorry, say it again?
When the NN.
Yes, yes.
It means you couldn't parse this. There's something there.
Yeah, I mean, I'd say NM has a wider role of just, I'd say like NA is kind of like it's not there. Yeah. NM is kind of like we had an error trying to get you a value.
So it could be, it could be a parse error. Or it could be
yeah, it could be like division by 0 too, right? Or something weird like that, I mean.
Sure.
Depending on what you want to classify. But the main thing is like a lot of values, like when we're doing reductions on the frame and stuff, we'll interpret NAs and M's differently. So we'll see that later, but yeah. Anyways, so basically, yeah. So our cell types have 3 values: the value, the NA, and the MM. So the value wraps a single value. It's basically saying there's something there, and here's the value. The NA is like, this is missing. The NM is this is nonsensical. There's a value here, but it's bad. So you can see it is very similar to option, except we've added one extra case. So option has it's here or not here. We have it's here, not here, or it's here, but it doesn't make sense. So obviously getting out single values is kind of not super useful for a lot of people. We generally want to get out entire rows or columns or groups of columns. And so we do that with basically something called calls. There's also rows. We'll get into that later. But the main thing here is we basically have a couple parts. But the first part is we're basically giving it the columns we're working with. So in this case, the type that you're giving it, like this horsepower, has to match up with the column type of our frame. So our frame's column keys were strings, right? They're the headers for the CSV file. And so one of those was HP, so we use HP here. And then we're basically saying that we want to extract the horsepower column as a double. And so that's what that does. And we'll get into how it works. But basically, you'll see here we get something called a series, which is basically a list of numbers that have keys and values. It's not a map because the keys can be duplicates. They don't have to be unique. And there is a natural order to them that may not be the sorted order. In this case, obviously it is, but you can see here that series as well have a natural notion of values or basically cells. All the values are cells, so they can be missing data in there as well. You can see here we have basically the key parameter for the series is the same as our rows. That's because we access the column, so we're getting all of the rows, the exact column from each of the rows. And then the value is just our value type. So we have the corresponding rows, which basically, where columns is selecting a column, rows is selecting a row. And now we're saying get us all the values in the row as a string. And you see it'll rip it out, and we'll get basically a single row, just kind of like a record of data as strings. Right, so this was basically a simple case where we had a single column, we're getting that out. Quite often, that's not all we want to do. You usually want to work with more than one column at a time. So you could, for instance, actually give it more than one parameter. So you can say I have only name and horsepower, and I want to give it as a two-tuple of string and double. So basically we're saying the name column is going to be a string, and the horsepower column is going to be a double. And then we finally run that, we'll get back a series, and you can see here it pulls out what we think it will. We have our rows, our keys, and our values are two tuples of like the name of the car and the horsepower. If either of those values is NA, the entire thing will be an NA. So how this works is it basically just has a generic type class called an extractor. And the extractor basically knows how to get values out of the frame, or out of the columns, basically. So by default, we really just have the one, which is, I guess two, but one that uses H-lists and then has support for shapeless as generic. But yeah, the main thing is that both these things have a size associated with them that we know at compile time. And so we use the number of columns that you provide, like if you provide a horsepower name, you have two columns you're working with. So we know we have two columns we're working with, and we use that size at compile time to guide the inference. So that's why when we're extracting one column, we can say it's double, and it works. And extracting two, we know that we have to work with something that's more complex, so like a two-tuple or each list of two size two. So here's a little example where we have a car case class with the three fields. We basically define our calls outside of here. Calls doesn't actually get any data by itself. It just creates sort of a description of how to get the data out of the frame. And you can just see here, we say not as car. This is thanks to shapeless. Basically, shapeless has this thing called generic. It lets us basically, given a car, we know how to turn that car into an H-list and how to turn an H-list back into a car. So we can figure out how to actually extract those values. We can know it's a string double. And when we get the values out, we actually get out the series, and it's actually full of cars, which is pretty nice. You see here too, I did define this outside. I found in practice that it's very useful to generally define your call, like how you're selecting your columns outside of the frame, not on like a per use basis, because that way you've kind of defined your way of extracting the values out as a type in one place, and everybody can reuse that. So the main thing is these rows and calls, it abstracts how we actually get values out of a frame. Pretty much all of the useful operations on frame will take a column, either calls or rows, and work with those to actually get values out. Because obviously in Scala we need to actually have a type in to pretty much do anything useful. It also lets us work the frame uniformly. So we had one get method that worked for both columns and rows. No matter whatever one you provide, it'll work. So you don't have to worry about getting the method names right. There's just one way, and you sort of define how you want to actually access the data, whether it's like along the row axis or the column axis. And so calls/rows are more than just saying like have more than just an add method on them. You can also you can map them, for instance. So we're in here, we have our calls. We're saying an origin field in our CSV. We want to get that as an int because it's just a number of 1, 2, or 3, and these correspond to some region where they're made. So in this case, we're basically just turning them into strings. We're saying, oh, if it's a 1, it's USA. If it's 2, it's Europe. If it's 3, it's Japan. So we have our, but yeah, so you can see the result type of this call is now a string. So we're basically saying when you extract this, we actually want to get it as a string. It'll do the mapping as it pulls the values out. Here. Okay, so anyways, just other operations too, there's more than this, but basically you can zip them. So instead of like saying name NHP as a 2-tuple, you can just get from both single values and just put them together and get back to still. You can also recover from NAs and Ms. So if you load a CSV and you want to basically fill in all your values with like the mode or mean or whatever else you want to do. There is a lovely recover function, so you can basically say, well, if it's NA, then just replace, in this case, we're saying if the horsepower is ever NA, just replace it with 100. And then when we go to actually get, like, say, this was the value that was missing before for the Mustang Cobra, when we try to get it now, it'll actually just give us it'll recover with the default value of 100 instead. Okay, so now we're going to move on to frames. And sort of what can you do with frames, some operations. This is just going to be kind of a wang bang, sort of just showing a bunch of different things you can do and kind of give you a feel for some of the stuff. So the first one's obviously just sorting. You quite often want to just sort things, so when you get them back out as a series, you have the order. So you just sort by just takes calls. So in this case, the horsepower is double and sort by that. You can see here, it's put all the NAs first. So we have like 6 cars that don't have any horsepower value. And then we go on from there. So grouping exists as well. Grouping is not grouping in the SQL sense. Basically, the main thing here you'll notice is that the row index has changed. So before it was an int, it was a row. Now it's changed into a string. What's really happened is that we've made our row keys into our origin, and then we've then sorted the frame based on the keys. This has a couple of things. If there's NAs, they'll be dropped, which is important to know. The other thing, of course, is that grouping is obviously grouping. What it really is equivalent to is like we basically just sorted it, and then there's another method called reindex, which basically swaps the index. It doesn't necessarily actually sort the frame. We can also map the frame. It's something you'll do quite a bit too. So basically, we say, okay, we want to extract some value as this, and whatever. We have 2 columns. This is the column we're going to store the result of this map into. So the actual function I'm doing here is I'm converting cubic inches to liters. That's because I'm Canadian and I understand liters. So basically, this is just a conversion factor. So we just have a function that takes cubic inches of the double, and we can just turn it into liters, and it'll get stored back in the frame. You can see here that there's a frame, and we've gotten our liters out, and they're sensible again. You can understand what's going on. A bunch of American cars, so obviously they're massive engines with pitiful amount of horsepower in that sense. So now we have moved on to join. So obviously, like the whole point of this is really to take 2 things, like 2 CSVs, and join them together, or 2 whatever you want to do and join them together. We're going to do kind of a toy example because it's easy. So in this case, basically what we have is we have a frame that has very simple data. It has a single column. The rows are basically our country or our region of origin. So if you just say Europe and Japan, we're basically mapping them to a more readable human version of the same thing. The series just has a 2-frame method. All it takes is the column key the single column is going to create for the frame. We get back the frame. Yeah, it's lovely. So now we're going to take our frame that we had grouped by the origin. So the key is now Europe, right? I don't remember if we slide back. We're going to basically drop all the columns but the name of the card because it'll fit on a slide. And then basically we're going to take that frame, we're going to join it with the frame we had defined previously here, and basically do an inner join, just outer joins, left outer joins, whatever you want. And then end up getting a frame with 2 columns, names, and then a human readable region of origin. Here, so yeah, this column came from by origin, and this column came from the original labels frame, and it's that's kind of the main reason why one of the indexes are not unique. Whenever we're doing joins or anything, we're doing it based on the row keys. And if all our row keys were unique, joins would be pretty boring. Okay, so then reductions as well. So I've just defined a bunch of calls up here, like to kind of easier to just define my calls up front, and then you don't have to worry about the types all the time. It's a little shorter. So basically, you can see we're calling ad-hoc get, so we're getting the horsepower as a series, and we're calling this value mean on the series, which is basically telling us that there was an average of 104 horsepower. I mean, keep in mind this data is like 30 years old or something. So back then, I guess that made sense, but not a ton of horsepower. There's other reductions you can call max. Quite a lot of good miles per gallon. I think most people here probably don't even get that. There's the ones like unique, so you can get all the unique values out, etc. You'll notice that every single one is always returning a cell. This kind of goes back to what I was saying before, which is like, so the reason why we have an A and M is that for an NA, we're doing a reduction, we'll just skip over it. It's just like, okay, well, it's not there, that's fine. You can deal with this in data. NMs are more saying that there's a value there, but we don't understand it, so we can't do the reduction. Like, how do you sum up X plus some value you don't understand? You don't. So we just bail out whenever we see an NM, basically. We can actually get a little fancier, too. The other reason why we have the keys are not unique is that we can do reductions by them, so this is more like grouping as you're thinking. So in this case, we have series again. This time we're getting the average horsepower by the region of origin. I really want to say country, but I have Europe in there. You'll see that, yeah, basically, obviously, American cars have a lot more horsepower on average, but you also see that they have significantly worse miles per gallon on average as well. And so all of these things, when you put them together, you can start doing fancier stuff. This is kind of terrible. I will show you how we can do this in a fun line later on, but kind of go through it. Basically, what we have here is we're first getting the mean by origin, so we're just getting a series with 3 values, which is like what we had before. Same with the count, so we're getting the number of cars in each from each country of origin or region of origin. And so retain columns once again just for size because it's slides. Basically, yeah, we're going to take our average miles per gallon, we're going to join them back into the table. Our table has, all of the cars in it. Our mean miles per gallon by origin only has like 3 values in it, so basically for each region of origin, I'll get the mean for that region of origin and apply that to every single car in there as a part of the column. We then extract out both miles per gallon and the mean as a 2-tuple. So basically, at this point, we have a series of strings to 2 tuples of doubles. We then map these, and we basically are just saying that, okay, we're going to take the miles per gallon, subtract the mean from it, and then square it. Probably see where this is going. We then take the sum of all of them by p, so we're back down to a series with just 3 values in it. And then we're basically going to divide. The zip map is basically like a join for series. It does an inner join and basically lets you give it a function instead because it has types. So in this case, we could take the count. So we have the sum of the differences of the sum of squares of the difference of the values by the mean, and then we're divided by the count, and so we have the variance. And then we're going to map this to the square root. So we have the standard deviation. So then I have the standard deviation of the miles per gallon for country of origin. You'll see that they're actually all pretty much the same, which means that the means we got earlier were pretty good representations of the actual horsepowers of the car. They all have kind of similar shape of sorts. So yeah, there's that. So I just want to very quickly go over what Framian is not, just so I don't get flack. But This is not about big data or distributed computing or anything like that. It really is all in memory. We're working with, not small amounts of data, but small amounts of data. So obviously, if you want to do bigger stuff, there's great tools out there already. It's also not a linear algebra library. We don't have any intention of being that. If you really want to, get a matrix out, then one of the libraries that exists out there, right, that are good at that. What it does try to do is it just tries to provide kind of a bunch of basic building blocks so you can build tools on top of it. So we have like our way of extracting values from a frame, which are columns and rows. There's this kind of fundamental concept of an index, which is reused in both series and frames, and it handles things like reductions. So it knows about the keys and everything. They can do the grouping and sorting as well. It can also do co-grouping, which is how like zip map and series and join and frame are implemented, and an operation called merge, which is a bit weirder. So it's kind of like a nice thing to do. And then our column types are basically where we actually stuff the data. There's kind of two types of columns. One type of column is a type column. That's main goal is really to be very fast and let you just rip through values as close to as quickly as you could with an array. So we can kind of do these things fast. And the other type of column is one that kind of lets you figure out how to get a typed frame out from a bunch of possibly other types of columns. They actually let you do the casting. So yeah, like I said, our hope is that this will be used to build more complex libs on top. We kind of started the Framian stats to do some basic stuff. I'm going to show you that we have the one-liner, so you can actually just use standard deviation here and get up the standard deviation. So in this case, origins are frames, so we're just saying we're giving the standard deviation for the column miles per gallon. Then here we're using there's a method to do ordinary least-squares regression on this. So miles per gallon is a dependent variable, and we can give it any number of independent ones. And then basically, once we have that, we have a classifier. We can basically then, I guess, rest really. And basically, we can try to predict what the miles per gallon will be based on the weight in the cubic inches. So you can see here we have a 5-liter engine, and we're saying, what's the effect of the weight? You can see that, as you go lighter, your miles per gallon increases a lot. Yeah, so that's basically it. We're trying to get people to contribute and use this. So if you want to start contributing, you can start looking at some of the issues we have and tackling the problems. Yes. Yeah.
So it sounds like you're saying it's a columnar data.
It can be either. I'd say like it's one of those. So there is two versions. There's a row-oriented frame and there's a call-oriented frame. So I would say like you should know more or less how your data is stored. It's like if you're doing CSV, I will say we do column-oriented by default.
For loading, row-oriented better.
Yeah.
Slicing and dicing.
Yeah, and I would say Framian, like, at least for our use case, a lot of it really is burning through columns. Like we have a column data, we're just, so like.
As long as you're doing more than just like the cost of just loading things, it's switching the column.
Yeah. And, yeah. It's definitely a.
There was a slide where you had it's like break.get something a map to meters, right? And
yes.
That function. Is that adding that column
yes.
to the frame?
Yes, it is. Yeah, it'll add the column to the frame. And actually, the behavior we have right now is that if the column exists, it'll drop that column first and then add it. And that was kind of I wasn't sure what the right behavior would be there, but I talked to a few people and they seemed like common use case would be that they're replacing a column with something that they've done. So
it doesn't return a new frame.
No, it always returns a new frame. These are all immutable things. We're not like copying all the data in the frame, but yeah, like it's definitely returning a new frame. So your old frame will still not have that new frame will. Anybody else? Sweet.
Thank you.